And that is really why TresActio is here. As you just heard, synthetic biology is amazing and it has great potential. And new technologies within genetic engineering are opening up new frontiers for a better and more sustainable future. But for any of this to matter, we need to be able to get these products out of the lab and into the world. When you want to make a new product, you typically start by generating thousands of candidate organisms. And it's then the job of scientists to take these and find that one organism that actually goes into production and has an impact. This is a really challenging problem. We went out and spoke with a lot of customers to hear how they do it today. And they do it in a funnel where they start with their candidates, and in a series of steps, they whittle them down until they find their next blockbuster. The problem lies in the middle of this funnel. Many companies still rely on shaker flasks. They don't provide any monitoring, and they can't control the process. So it's like looking for a needle in a haystack, blindfolded. The next step is lab-scale bioreactors. They do provide monitoring and control, but they're too slow and don't offer enough throughput to be used on their own. And this is where TresActio comes in. We want to fix this problem in upscaling. Our vision is to improve the cell culturing labs through automation and data-driven approaches, such that the scientists can do what they're great at, and machines can do the rest. We believe in having a big vision, but starting small. So we started out by talking to our potential customers, more than 10 in fact. And based on their input, we designed a minimum viable product. We spoke with Novozymes, who were particularly interested. And they saw the importance of what we're doing, so they signed a commercial letter of intent stating that they want to help us develop through pilot tests and of course purchase it once it's done. We've also spoken with Siemens Technology Accelerator, who have some interesting and unique sensor technology that they're willing to make available to us, because they recognize the importance and the value of the problem we're solving. So this came together to our design. It's completely wireless, sits on top of a flask. It has a sensor probe going into the culture, monitoring key parameters. And we have 3 liquid containers for controlled fed batch fermentation. What really central is, this is very easy and very fast to use. So the workflow is familiar to anyone that has worked in a fermentation lab. You start by autoclating the culture as well as our filter cap. Then you design your experiment using our easy-to-use software platform. Then you assemble it by clicking on the electronics and liquid containers. Lastly, you inoculate it, put it in an incubator, and you're good to go. And you can monitor everything online from the comfort of your computer. Comparing our product to what is available today, we see that in terms of features, such as the ability to control pH, add nutrients, and so on, we are very competitive with lab bioreactors. And of course, we blow shaker flasks out of the water. But when we talk with our customers, they say again and again, the things they really care about and what drives the economics is the data quality, of meaning how many strains can you really get good data on, the speed, so how quickly can you set up an experiment, and the cost, which essentially translates to how many experiments can you run in parallel. And here you can see our MVP already is a very attractive business case. There are other approaches to this problem as well, such as microwell bioreactors. They work with very small volumes, leading to several problems. For instance, you can't take as many samples as you might want during an experiment. There are parallel bioreactors, like the Amber 250 system, but these are very inflexible and cumbersome to work with, as well as prohibitively expensive. And lastly, you can outsource it through a contract research organization or service provider. This is also problematic because there's a loss of know-how and innovation by outsourcing these things. So in short, We reduce uncertainty when screening, which in turn provides improved production organisms for our customers, which improves their margins. We've did some market research and found more than 7,000 companies that conduct relevant kinds of research that could use our MVP. These companies already have a high R&D spending, and from talking with to our customers, we know that they're willing to pay to solve this problem. So that's what we're doing right now. Right now we're focusing on bringing our MVP to market by partnering with large companies like Novozymes. This will allow us to mature our key technology, but really we're interested in making a mass-produced product that we can get out there and collect a massive data set. And using this, we will pave the way for what we want to do next, which is a fully automated system that can set up and conduct an experiment without the need for human labor. Such a system will be able to fully take advantage of the new techniques within machine learning and data-driven approaches. This has an even greater commercial potential, and we believe this is what's needed to disrupt the strain development process and truly bring about the biological future. And to do so, we have an excellent team of diverse technical backgrounds, from data science, product development, sensor technology, electronics, and software. We're really covering all the bases needed to develop such a product. And to support our efforts, we have some very strong advisors with experts with expertise within commercialization and fermentation technology, as well as experienced entrepreneurs who've been through this before. So with their help and the help from the excellent BII team, we're right now validating the robustness of our technology and validating it in the market by talking with customers. Next, we'll integrate this into a limited feature prototype that we're testing at Novozymes. Once that's done, we'll develop the full MVP and test it more broadly with both small and large companies, universities and CROs, because we're really solving a general problem here. Once that's done, we're ready to set up production, which will take another 6 months, and then by the end of the third quarter, 2020, we can ship our first product. Up to this point, we've been able to rely on soft funding, and we've raised almost 1 million crowns. And we believe using soft funding, we can get all the way to the Novozymes pilot. After that, we need a new investment. Siemens Technology Accelerator, that I mentioned before, are interested in coming on board as an investor. But we would really like a local investor to come on board as well, that has some more experience with the industry and with the biotechnology side of things. At TresActio, we believe that just because biology is complex, the technology powering it doesn't need to be. So if you agree and want to help make this a reality, come grab me afterwards or shoot us an email, info@tresactio.com. Thank you.
Thank you very much, Toke, for the fantastic presentation. And now, Roger, what do you think about the solving problem of strain selection?
Thanks for a great presentation. So I was just keen to hear more about the core technology here. So what are the parameters that are being measured? What's being manipulated? Can you go into any more detail about that core of how the technology actually works?
So the core technology revolves around some sensor technology that allows us to make very cheap single-use sensor probes. This enables a workflow that gives us this high throughput. We can monitor the pH, glucose, as well as the dissolved oxygen, which we have very good data on. And we're looking into some technologies for measuring the biomass as well.
And the IP around that is what? What's the, if you could describe the nature of the IP briefly, that would be great.
So there's some IP on the sensor technology, and we've done a freedom to operate analysis, an initial freedom to operate analysis with the help from SACO and through BII. So we can see that we can do what we want to. There's also some IP that Siemens is interested in putting into the company that will give us further protection. But in terms of a defensible edge, a lot of it will come from the ecosystem and the data platform.
Great, thank you.
So on top of that you can follow the cell growth, you're getting data on the cell growth. What is the most important value proposition of your product? Is it time? Is it success rate of the cell growth, or what is it?
So there's a pressure on industry to have a consistent process where you can get it right the first time. So right now there's a lot of uncertainty in the process, and you risk either taking forward candidates that you shouldn't have, then need to go back, or maybe screening out the things that you were actually looking for. So you might actually end up dropping a blockbuster on the floor. I mean, on top of that, of course, we also help shorten the time to market by reducing the funnel, or making the funnel shorter. Does that answer your question?
So what is the most important milestone that you have achieved during this BII program?
Well, we've done a lot during the BII. I think it's really important for us that now we know what we want to do as a company. When we came in, we had a problem and some technology, and really didn't know how to fit this together. So we have a lot better strategy right now, and we know that we're in a space that we're allowed to be from the freedom to operate.
Thank you, Toke, for a very nice presentation. When I went to university, I learned that you get what you screen for. So if you screen for growth in a shake flask and you optimize for growth in a shake flask, you get microbe which grows well in a shake flask. So have you any experience and any data on the fact that it actually scales to large scale production?
That's of course one of the key questions for us to answer, and we don't have that data yet. We've spoken with the labs in the Netherlands as well as in Sweden that can help us by providing access to pilot scale, because of course that's what it's all about.
And just one final question: is there a synergy with the Bifrost first presentation we heard?
There very well might be.
Thank you.